Okay, intermediate, welcome back. This is part 2 of 9.6. This is the second video. So let's start to talk about how do you simplify radicals when it's a variable. You're stuck with a variable under the radical. So it's the same concept. You want to make this a perfect square so that you can force it out of the denominator, because right now you cannot take the radical as it is. So I'm going to give it a twin. So I give a twin to both sides. It's the denominator that determines what you give to both sides. So now I've made this a perfect square, so I can simplify that. So w squared comes out as a w. And that's the final answer. And just remember, you can only reduce non-radicals with non-radicals. And you can only reduce radicals with radicals. So for instance, this right here cannot reduce because this is a radical and this is a non-radical. They have to be the same category to be able to reduce. Okay, let's try another one. So this is not considered simplified because you have a radical in the denominator. So you have to force that out. It's not a perfect square, so it's not going to come out on its own. You have to actually force it out. So you're going to make it a perfect square by giving it a twin. Whatever you give to the denominator, make sure you give the same amount to the numerator. So things under the radical can combine with things under the radical. That's how it works. This is a radical. This is a variable and a number, so they're just going to combine. This guy on the bottom simplifies out, so it's the square root of 2x over x. Okay, so the concept is still the same that we just did in the previous video, that you just have to make it a perfect square to pull it out of the denominator. Okay, so let's do some examples that are a little bit, they've got just like more stuff going on. So actually, before we do these, let me do this one and then I'll come back to those two. Let me move over to this guy here. Okay, so try to remember that whenever you have a fraction, the first thing that should go through your head is, you know, can I make that simpler? Is there a way that I can make that easier for me to solve? So if you notice here, you can reduce the m's and you can reduce the n's. So go ahead and do that first. So I have 2 m's in the numerator, 3 m's in the denominator, so that would leave me with 1 m in the denominator. I have 5 n's in the numerator, 1 n in the denominator, so that's going to reduce to be 4 of them. Okay, so now I'm going to break the radical. So I have two things going on here. I have to simplify out the numerator, that's a perfect square, and I also have to get the radical out of the denominator. So in this case, it needs both a 7 to make the 7 a perfect square, and it needs an m to make the m a perfect square. Okay, so this n to the 4th came out as n squared. This 7m is under. We made the denominator a perfect square. And then we can simplify it out because it is a perfect square. Okay, and then there you go. And nothing else simplifies here because you can only reduce outsides with outsides and insides with insides. Okay, so that's the final answer to this one. Okay, and let's do a little bit more in this video. So same idea here. When I see a fraction under the radical, the first thought in my head is, can I reduce that? And for this one, what do you think? Right, you can't reduce this one. 81 is not divisible by 2, and there's no common variables here. So, okay, so we're stuck dealing with it as it is. So let's go ahead and break it into 2 parts. Okay, and now I'm going to, you know, it sort of depends just what step you want to do first. So I'm now going to just simplify what I can here. So the 81's already a perfect square. To be a perfect square, it has to be an even exponent. So we're going to have to make this, we're going to have to pluck one off. So we're going to make it c to the 4th times c. All right, so in terms of the numerator, I can pull out the 81 and the c to the 4th because those are perfect. So since they're in the numerator, they pull out to be in the numerator. Now, you can't have this radical in the bottom, so I have to both give the 2 a twin and the d a twin. So they both need to be perfect squares. What's under the radical will combine with what's under the radical. So then this is going to be 2cd, because that's still left under. These won't come out. This in the denominator, we've made this a 4d squared, which is perfect. So I can now pull out the 4 and the d. So that's going to come out as 2d, 9c squared, 2cd. Okay, and that's the answer to that one. We're sort of getting towards near the end to the radicals, so we're almost done with this chapter now. So the topic's getting a little more difficult, but you guys can handle this. Just keep as long as you're using your rules correctly, you're fine. Now, I'm going to make a suggestion here. I do think that it's easier just, at least with the variables, just to make them a perfect square right away. So instead of me plucking one off here and making it a 6 and a 1 in terms of the exponents, I think it's easiest just to make it, just bump it up one. Like if I bump it up one, it's a perfect square and it's less steps. It's just a suggestion. You don't have to do it this way. So instead of reducing it first, then making it evening, making both sides even, and then reducing it again, like taking the perfect square again, it's easiest just to make it a perfect square right away, and then this comes out. Now there's no perfect square in 22, and there's no perfect square in W, so that's just going to stay. And again, you cannot reduce a radical and a non-radical, so then this is the final answer. Okay, gang, I hope that helped. We'll do a couple more problems from this section, but I hope it's going well. Catch you again soon. Bye-bye.